There we go. Oh. Okay, Chris, a little bit of a stir there. There we go. Right. So,
Okay.
I think we'll just crack on today, Sean, and we'll see how we get on, shall we?
Okay, so I thought we would talk today about radical solutions for climate change.
Oh, let's write this down. This sounds interesting. Radical solutions for climate change. And just to warm up a little bit, let's see how well you're pointing is today, see how well your hands are working. The thing that we're going to be talking about is, let's just do climate. C-L, very nice. I-M, we're just up A, T and E. Climate. Climate change, yeah. Okay.
First condition that would be required is that we come up with a non-carbon energy source.
A non-carbon energy source. Ooh. So the type of energy source that we need to find is N-O-N-C-A, very nice, R-B-O and N, non-carbon, good.
We would need it to be technically feasible. So having something that's just pie in the sky but not technically feasible isn't going to work.
Technically feasible. Could you give me another word for that? If we said we want something that is technically feasible, could you give me another word for that? What would you say? If it's technically feasible, it would be P. Oh yes, that's a good one. R A C T. Oh, N wouldn't make sense. Touch the T again. T I C A and after the A, yes, it would be practical. Practical.
We need it to be able to scale up very quickly.
Able to scale up quickly.
It's no good if it can only be done on a very small scale.
Small scale is no good. Give me an example then, Chris, of what would we mean by if it was something was done on a small scale. M A Y B E maybe W I T keep it going, maybe with O N E 1 T H I N G. Oh yeah, that's good. Yeah, something on a small scale. That would mean maybe if you did it with just one thing, so maybe, I don't know, if you were just able to do cars but nothing else, I don't know, maybe.
Yeah, or you know what I was
thing.
thinking of is like how they have those little portable solar powered units that you can hook up to power a radio.
Oh
but
yes,
it
yes.
can't be scaled up to power a car, for example.
Yeah, that's a better example. Yeah. Yeah.
So the next condition would be that it could meet all of our energy demands for cars, for houses, for factories, for farming.
Okay, so number 2, it would need to meet all our energy demands. So 2 examples would be for F, A, R. Oh, don't wobble. So touch the R again. F, A, R, M, I, straight to the letter, N and G. That's one example. Another example would be C, all the way, C and, come on, try it on there, C, C, A, yeah, R and S, very nice, yeah. Another example would be cars, so 2 examples we said, farming and cars, but for everything, for powering the electricity in our houses, all the street lighting, powering the factories, everything, yeah.
So given how little time we have before there'll be really significant climate change, what the author was suggesting this radical solution was a massive nuclear energy program. And I'll tell you a little more about that.
Okay, so this particular author was suggesting the solution would be a massive nuclear energy program. Just for practice, we're just going to do nuclear. Just go straight to each letter. N-U-C, N-U-C, L-E-A, and touch the R, nuclear. Yeah. Massive. What does massive mean to you? Hang on a minute. Massive means E-N-O-R, that is good pointing, M-O-U and S. I knew you knew what it meant. We were just practicing really to see how your pointing was flowing, so that was really good. Massive means enormous, yeah.
That's a great synonym.
Oh, don't. I can't say it either. I'm not going to even try.
So I was quite surprised by a few of the facts that I learned about this, because I was initially quite, let's say, resistant to the idea of nuclear power. So the first thing that I learned was that the speediest drop in greenhouse gases in Europe was in the 1970s and the 1980s in France, while they transitioned to nuclear power.
All right, so the speediest drop in greenhouse gases. When did it happen in France? Sorry, was in the when did you say?
1970s and 80s.
In the
1970s and 1980s.
to 80s. So where did this happen? Where did this happen? The country was F R A N C E. And Sean said that he was surprised by this, that this is where the speediest drop in greenhouse gases happened, when they were basically switching to nuclear energy. Would that surprise you? Y-E and yes, okay, so you're surprised as well. Oh, well, let's find out why.
So the greenhouse emissions went down 2% per year, while while they transition from fossil fuels over to nuclear fission.
2% per year. Okay, yeah.
Now, I was flying over Germany last year, and I was looking down and seeing all of these solar panels, because Germany's done a great job of moving toward renewables. But with all of the effort and the hundreds of billions they put into renewables, they basically stayed flat with their emissions over the last period of time. Whereas France, over the course of this decade-plus period, went down 2% a year. So quite a massive difference.
Yeah. Anything to say? W H Y W. Oh, lift him back. W A S Y was. Come on. It's a good question. T H A T. Why was that? Why was that? That's a good question to ask.
And it seems to be that in both cases, in France in the 70s and 80s, and in Germany over this past decade, the power use increased in both of those countries. So the population is growing, the economies nuclear fission was so great that it was able to take over a much greater percentage of the total power use of the country.
Okay,
as compared to
we just lost your signal.
Let's say solar power.
We just lost the signal a little bit there, Sean. But we got what I picked up was that the power use had increased in both of those countries. And then we lost a little bit, and I caught the end bit, which I think was you were saying that the nuclear option had managed to use more of that or provide more of that increase in power use. Is that right?
That's right, and that comes back to what we talked about initially, is that the nuclear power can be quickly scaled up to replace much greater amounts of power that we're using in our economy.
Okay. Right then, so as the power use increased, what was the advantage of the nuclear option then? I T C O U L and D. It could. The advantage of the nuclear option was that it could B E S C A L E D. It could be scaled. U P Q. After Q, you've always got a U I C. This is good pointing. Keep the flow going. After the C would be you're there. K, L and Y. It could be scaled up quickly. Very nicely done. It could be scaled. What's that, sorry? That's all right, the time. We've got plenty of time. It could be scaled up quickly. Yeah, it's only 9:45. There.
Mm-hmm.
Yeah, we'll just try here for a while because your pointing is better when you're sitting in a nice stable position. So we'll try just working on your tolerance to stay here for a little while. I'll put a pillow on there to make it comfortable. There.
Now, there's a respected climate scientist. His name is James Hansen. And he says that in order to avoid dangerous climate change, the world needs to drop fossil fuel pollution by 6% a year. And as a reminder, the greenhouse gas emissions or the pollution stayed flat in Germany, and they went down 2% a year when France had a big nuclear program.
Right. So James Hansen, the scientist, said that fossil fuel pollution needed to go down by, and let's see if you can handwrite this. Let's see if you can handwrite the number. How many percent was it? You heard it. Ooh. Okay, I'm going to show you. It was a 6. We're just going to go round and down, down and round. Right, you have a go. And round again, 6. And then we'll do a percent just for the sake of it, which is just a line like that. So do the line like that. That's it. And we'll do a little circle on the top and the bottom. Very neatly. Let's have a go. Little circle there. Go on. There. And another one there. Very neat. That was good. By 6%. Yes. There.
Now, the US is a huge energy consumer. And so one of the downsides of nuclear, there's 2 general downsides to nuclear. One is the cost, the upfront cost, and the second is the danger.
Okay. So the problems in going for the nuclear option, somewhere like the US, which is a huge consumer, would be the cost, the upfront cost, and the danger. What do you know about the dangers of nuclear power? Anything? Just tell me one thing. T H E R E there C O U C-O-U-L. You're doing so well. Go on, your pointing is so good. There could be E A L E. Okay, that's good. A. After the A. Was that L or K? You did L, E, touch the A again. A. There could be a leak. There could be a leak. And what would that be? If there was a leak, what would it be of? It would be a leak. O of R A D I O, radio. A C T. After the T, you were there. I V. After the V, of radioactive. M A T. M A T. Okay, T. M A. Touch the T again. T. Come on. E. And you were there, just touch it. There could be a leak of radioactive matter. Okay, yeah. Of radioactive matter. There we are. Yeah, that's one of the dangers of nuclear power if there was going to be a leak. Yeah, and there have been accidents, haven't there? There was the Japan and the Chernobyl. They were the big ones that we know about.
Yeah, there was the 3 Mile Island one as well in the US.
Oh, right.
That was in the late 70s. That might not have been as big a story for you guys.
No. I'll have to look that one up. Yes.
So the cost, and we'll talk a little bit about the safety in a moment, but the cost would be $7 trillion to build 1,000 nuclear plants. And that would allow 25% of all the energy in the US to switch away from carbon-based fossil fuels and to be emission-free, 25%. For 14 trillion, 50% of the energy in the US would be fossil fuel-free or greenhouse gas emission-free, carbon neutral.
Right. Pretty impressive, aren't they? What do you think? ITSEEMS, it seems. LIKE, seems like ALOT, seems like a lot. That was a good flow then. Seems like a lot. O. Don't get stuck. Touch the O again. O. Next letter is. Go on. Go on. You're just getting that little frozen feeling again, aren't you? N. After the N. Go on. Keep it going. E. Y. It seems like a lot of money. T. O. 2. S. Go on. P. That's just an impulse. You sort it out. Good. See, you've sorted it. A lot of money. 2. S. P. E. N. D. It seems like a lot of money to spend. It does, yes.
Yeah, I thought the same thing, like a tremendous amount of money. But here's some things to consider.
Just try and listen. There you go.
Earlier this year, with the COVID crisis in the US, the US government spent $2 trillion giving a stimulus, which was unemployment checks and payments to businesses. So $2 trillion for COVID. For $7 trillion, you could have 1,000 nuclear plants that replaces 25% of the fossil fuel energy that's used in the US. So it seems like it's, in a way, doable. Now, US GDP, the amount that the US economy produces every year is 21 trillion. So for a third of that 21 trillion, you'd basically have 25% of your energy be greenhouse gas free. Or for 14 trillion, for 2/3 of 1 year of your GDP, you would have half of your energy from an ongoing basis, hopefully, covered by nuclear fission. Now, last number, I know there's a lot of trillions being thrown around here. The last number is the US budget. So the US, normally the US government spends every year. Well, in 2020, their budget is just under 5 trillion, but they added 2 trillion extra because of COVID to that as a kind of emergency spending. So normally they're spending 5 trillion, just to give you a sense of what it would take to build all these nuclear power plants and have a radical solution to climate change.
Anything to say? I W O. You're getting a few more impulses there. Let's just try taking that hand down. There. I W O. N D E R W H A T. I wonder what. T H E. I wonder what the. To keep that hand down. I wonder what the. Okay. I wonder what the P E O P L. After the L must be E. I wonder what the people W O U. Good point. W O U L, and after the L D. Would. T H I N K A B O U T. I wonder what the people would think about. Is that T? Yeah, go on then, touch it. Oh no, it's S. S P E N. S P E N. Go on. D and I and N and G. I wonder what the people would think about spending. And I can see that you're getting a little bit tired there, so I'm just going to finish it off for you and you can tell me if I'm right or wrong. So you're thinking, I wonder what the American people would think about spending all that money? Is that what you meant? Yes or no? Oh, you just, yes, yes. I wonder what the American people would think about spending all that money. It's a tricky one, isn't it? Because sometimes
it is a tricky one.
Seems like a good thing, seem like a good idea, but then if it's not popular with the people who are in power won't make those decisions because they need to maintain their popularity to stay in power, don't they? So
True.
there's always that balance, isn't there, that price to be paid, yeah? You know, it might be best for humanity, but if you're going to get voted out of power, then you're not going to implement it, are you?
Definitely. And you know, there's a politician in the U.S. named Bernie Sanders,
Yeah.
and another politician named Alexandria Ocasio-Cortez, or AOC. And so Bernie Sanders and AOC are kind of known as the politicians quite far on the left. And so they have ideas like they want to pay for university for all the students, for example. But they also put forward this proposal last year called the Green New Deal. And the Green New Deal was meant to move the economy to a much lower carbon output, much lower greenhouse gases, and really address climate change. And so on the left, on the far left, that was quite popular. On the middle left, people weren't really ready for it yet. And on the right, like Donald Trump and the Republican Party, I'd say most of them were pretty strongly against it. But the cost of the Green New Deal over however many years they're going to implement it was $93 trillion.
Oh my gosh.
So, yeah, compared to the 14 trillion.
A lot more, yeah? Yeah?
Yeah, for 14 trillion you could get half of your power replaced by nuclear power. So when you compare it to that, it actually seems cheap.
Yeah.
Yeah.
Just carry on a little bit, Sean, because I feel Chris's pointing was getting a bit tired, so we'll listen a little bit. And,
Okay.
Yeah?
Okay. So the the cost is definitely an issue, and I think it's an important one that you brought up, Chris. What's really interesting with this is that it's achievable with current technology. So if the cost wasn't an issue, we could basically address climate change and go, carbon free, starting next year, in a very dramatic way with building all these nuclear power plants that we could probably build in the next 3 to 5 years. So we've got things like renewables, wind, solar, and hydroelectric that also cost money. And as I mentioned, Germany, whose carbon emissions have been flat since 2009, they've spent 580 billion renewables, and the cost of electricity in Germany for the citizens has gone up 50% during that time. So with all these trillion-dollar numbers that we're talking about for a country like the U.S. that's obviously it's a bigger country and it's got almost 400 million people in it compared to Germany. I think Germany's got more like 80 million. So 580 billion, it's not that much. We're not in the trillions, but it is a smaller country, and everybody's paying 50% more in electricity. Whereas in France, there's 1/10 the carbon emissions per unit of electricity because it's so heavily nuclear, and they pay half as much for electricity as compared to the German people.
Yeah. So France pay half as much. Is there any comments that you'd like to make? It is. Just do a couple of words at a time. It is. It is making. Ready? Yeah, go on then. T, H, after the H, E, it is making the N, U, C, L, E, after the E, go on straight to the letter, straight to it, A, R, it is making the nuclear ready? It is making the nuclear O P T O P T oh, take the hand down there. It's gone. See? Nuclear OPT. Maybe use the other hand for a little bit. That one a break. Put it in that way. OP. Do the T again. T I O N S E. Very good. E and seam. M O R E. Seam more. A T. Good. After the T, lift your elbow. T. Oh, that was a Q. R A C T I. Go on, touch it. Touch it. V and E. It is making the nuclear option seem more attractive. That was what Sean said. I think it is, isn't it? When you start looking at all these facts and figures, it does make the nuclear option seem more attractive. I think it's quite interesting, Sean. I think there's the logical side of you that looks at the sort of the facts and the figures and the costs and the benefits, etc. But this is just on a personal level, Chris, I'm talking about. For me, on a personal level, there's the emotional sort of feelings that I have, which may be irrational even, but there's these strong, I have these strong emotional feelings that make me very wary of nuclear power. And whether that's because of things like nuclear bombs and seeing the damage that they can cause, and seeing the after effects of things like the Chernobyl disaster, it's hard to put those things out of your mind, isn't it?
I completely relate to that. I feel the same way. Like, the more I read about it rationally, I'm like, oh, you know, this really makes sense. But there is some type of internal aversion to it because of those accidents.
Yeah. Good, down you come, Chris. You're doing so well. So proud of you. I'm just wondering, Chris, whether you've got is there anything that you think about where logic tells you one thing, but your emotions tell you something else? Is there anything that you have? Any thoughts that you have? I-K-N. Come on, move your legs around, get yourself in a good position. O. After the O would be, come on. I know. T. H. A. T. P. E. O. P. L. E. I know that people M. A. Y. May. I know that people may. A. S. K. L. O. G. After the G. Come on. I. C. A and L. I know that people may ask logical was that R or Q? I wasn't sure. Q. You ready? Have a look. Hold the pencil. Q. Do the best you can. U. Q, U. You just reposition a little bit. E. S. T. I. O. N. S. Logical questions. A. B. That was T. A, B. Is that an accidental T? O, yes. U, T. Break. I know that people may ask logical questions about anything to say? W. H. Y. I. You're doing fine. C. A N N O T. Why I cannot. Go on. I know that people may ask logical questions about why I cannot. Ready? Why I cannot. J. Is that right? Sorry. Go from cannot. I wasn't sure. We got a bit wobbly then. Why I cannot. T. X. TX wouldn't make sense. T. Y would, yeah. P. E. Why I cannot type. W. H. A. T. Y. What I. Go on. W. A. N. T. What I want. Go on, don't freeze. T. O. To. What I want to. S. A. S. A. SAS wouldn't make sense. Touch the A again. To lift your elbow. SAY would make sense, yeah. I know that people may ask logical questions about why I cannot type what I want to say. Yeah. That's a good point. Sometimes people do see students like you using letterboards and pointing out their thoughts, and you're right, sometimes people do say, well, why doesn't he just type it?
Yeah, I think we understand, Chris, why, and it totally makes sense to us why it's difficult for you to do that, and why it's difficult for some other young adults like you, who have autism and the dyspraxia, what makes it difficult to use your body. So we get it, but I think a lot of people, they reference themselves, and they think if I couldn't speak, but I knew how to spell and read and write, I would just type it out. And so it's hard for people to relate to somebody's experience if they haven't experienced it themselves.
Yeah. Any more? Did you want to say any more about that? If you want to. We're just having a little diversionary chat here, aren't we? I. T. It. Go on. Your hand. Yeah, your fingers are fine. It. I. As it is. H. A. Touch it. Touch it. Touch it. Touch the A again. A. R. D. It is hard. It is hard. It is hard. Come on. T. O. 2. E. X. P. L. A. I. After the I. N. Okay, it is hard to explain. Yes. Yeah, I know. It is, as Sean said, if someone else doesn't have that sort of experience of their body not kind of cooperating with what their brain is thinking, it's hard for them to understand, and it's hard for us to explain. But you've done a great job in some of the things that you've already written and already shown, and the fact that you let us video is really helpful to a lot of people. It's definitely helpful to a lot of parents who are thinking that they might try doing RPM with their children when they see the challenges that you face and how you are able to overcome them. I think being able to see it is as good as being able to just use words to try and explain it.
Yeah, I agree. Even it's much more powerful to see it in action.
Yeah. Okay, let's just carry on then. We've got another, say, 10 minutes.
Okay. So,
Yeah.
currently, nearly 35% of the U.S. nuclear power plants are at risk of closing or slated to retire early. And natural gas and coal will fill the void for power plants, so that would mean a 4 to 6% increase in U.S. emissions. So even if we weren't going to have a massive expansion of nuclear power, it's probably pretty important for climate change to just update these nuclear power plants that currently exist rather than allowing them to close.
Mm-hmm. Yeah, so they need updating instead of being allowed to close. Otherwise, we're going to see even more of an increase in the emissions.
Now, what I think, so you and I both maybe feel drawn towards emotionally is, renewable energy that is clean energy, that's greenhouse gas free, but comes from sources like hydroelectric and wind and solar. And I guess there's some really good news here in New Zealand. We're quite a small country, but 80% of the electricity in New Zealand comes from renewable energy, primarily hydropower and geothermal power.
Oh.
So part of that is kind of we're lucky geographically. So we've got volcanoes, and there's a lot of geothermal power that comes from that. And we've got a lot of, waterways and waterfalls and dams down in the southern island that create a lot of hydropower.
Do you want to move position, Chris? Yeah, we can go and sit there if you want. You found that's going to be a bit more comfy too. We're just going to swap chairs. Move position. Go on. Pop yourself there. There we are. Yeah. Oh, sit up. Keep sitting up there. I'll just move Sean around so we can see him still. There. That's it. Good. You can still see us, Sean. Yeah. There we are. Okay. Yeah. So Sean lives. Where was it? N E W U. Ooh, not the Y. 1 over Z E and A and come on. L and N, A and N. And D. Yeah, Sean lives in New Zealand, where they're lucky because of the landscape and where they're situated, that they're able to use lots of renewable energy sources from the volcanoes, the dams, hydroelectric power, etc., etc. I don't think that would quite be possible in the UK though, would it? Do you know, just because we have looked at things like this before in the past, just out of interest, in the UK, what have you noticed that we've been doing a lot in terms of renewables? W. You have to lift your elbow. I. N. Not the E. D. Wind. T. Yes. U, R, the elbow, then you can reach B, ooh, I, finish it, N, E, and yeah, wind turbines. We see more and more of those as we're driving around, don't we? And even offshore as well. There seems to be more wind turbines. I haven't got any statistics though, maybe we could have a look later to see.
You know, I did have a look, Sue, and I was really surprised that the UK currently, 40% of its electricity is provided by renewables. So in New Zealand it's 80%, and in the UK it's a really quite a positive, 40%. I was impressed.
Yeah, yeah. Oh, that's good to know, yeah.
Yeah. In the US, you might be curious, it is 11% of the total US energy consumption is renewable, and about 17% of the electricity generation.
Right.
So, you have got, the electricity tends to be a little more highly renewable in each country. So in New Zealand, we've got 80% renewable electricity, but our overall energy, only 40% of it is renewable.
Right.
And so your electricity figure is 40%. Your overall energy was not, I don't have that information.
No.
So, but it's going to be lower than your 44%.
Yeah, just another few minutes, that's all. Just kind of, I think we're up to the point of wrapping it up now, Sean, if we can, for now.
Okay.
Come on, let me just sit down while we summarise.
Yeah.
Ba-ba-ba.
Yeah.
So, in summary, there's a lot of really positive things happening to address climate change with renewables, and also we've got solutions on tap like the nuclear solution. And I really think with the nuclear solution, and maybe with all these solutions really, it's important not only to look at the facts and the figures and the data, but also to look at what is our emotional reaction. Because if most citizens, if most people have the emotional reaction that, let's say, Sue, you and I had to nuclear power, it's really going to affect what governments are willing to do and what decisions they make. Mm-hmm. And, we really want to make sure we're coming from a place of, like, maybe there's some value to that emotional reaction, and maybe we should look a little more closely at the dangers. Or maybe it's something that is actually important for us to overcome, so we can embrace something that actually could be really useful for humanity and for the health of the earth.
Any final comment, Chris, on that? Have you got any final comment or any final thing you'd like to say? T, H, E, the, T-H-E, so the, go on, get your thought out. Ooh, I'm going all over the place there. Think about what you want to say, where you want to go straight to it. The, word. D, E, C, I, S, I, after the I, come on, use your finger if you want, after the I, bend those and get your index finger because then it's clearer. Your fingers are all stuck straight. Alright, use a pencil then. S, I, after the I, come on. O and N, the decision. I, is, N, O, after the O, T, E, A, after the A, S, and after the S. Right, touch the S again, S, and then it would be E, A, S. See, this is why it's easier when we're sitting on that other chair. Go on, E, A, S. What's been going on with your hand? T wouldn't make sense, but Y would. I think that's probably where you were heading. The decision is not easy. The decision is not easy. You're right. I think that we'll leave it at that on that final point. It's not an easy decision. We have to consider all of the angles, and I don't know, maybe you have to almost put to people, well, these are the options, these are the costs, you know. If you want a totally safe renewable source, the cost of it would be in pounds or in dollars, and the, you know, you'd have all of these, for example, wind turbines all over our countryside. Do you want to pay that cost, you know, or balanced against the sort of the risk benefit analysis of the nuclear option? And who knows, so there's developments happening all the time, isn't there? Who knows, scientists might come up with another form of energy that we haven't even invented yet. So
true.
in the next 10 years there might be something totally different. Okay, Chris, you have a little wander, take a little break. Well, you don't have so well. Just turn this. There.